that concludes my presentation. Thank you.
Yeah, thank you. Great. Yeah, so let's go to the next group, January, Joseph, and Timothy Fu.
Okay. Hello, everybody. My name is Joseph Girani, and is Timothy here?
Yep, right here.
Okay, turn on your webcam so I can be sure. Oh, I see you. Cool. All right.
Can you hear me?
So today we're going to be talking about shellcode and the seed labs for the shellcode project. And before I get into any of the tasks, we need to establish some background. So there's a big difference between the terminal, the command line, bash, which is a shell program, and the command prompt. So a terminal would be like a program such as console, which comes with KDE, xterm, tilde, or the default Seed Labs has a GNOME terminal or something like that. And what exactly is a terminal? In the old days of computers, when many people had to use mainframes, they had these monitors, right? They had these monitors that had basically no computing parts in them. All they did was just link up to the mainframe, and that was a so-called terminal. Like, this monitor wasn't doing any of the computing. The mainframe was doing all the work. This is just like a link, kind of like how these days you can stream a game from Stadia or stream a desktop through a VPN or something like that. That type of idea. The terminal emulator is really what it is. What we end up using. And Bash, the born again shell. This is like a language, a set of rules and stuff. If you want to know what shell program you're using, you would type echo $0. The command line, that is just the line that you're writing your commands on. It's nothing else. And the prompt, I'll show you that in a bit, but it's basically just the thing that you see when, like, your username and the computer name, you'll see that. I linked this video made by Luke Smith. Let me see if it opens. Yeah. He explains in much better detail. You might want to check that out. But yeah, back to this. Timothy,
So,
hold on.
Yeah.
Yeah, go ahead, Timothy.
Can you guys hear me okay? Hello? Okay.
Yeah.
So before we start the seed lab itself, we need to establish some foundation first. So we need to have a Linux distribution installed. And not only that, we have to install the NOS-M itself, which is an assembler and disassembler for Intel CPU's x86 architecture. Since it's x86, this assembler will also natively support lower bit, like files such as 16 and 32-bit, which will be relevant since our assembler file will be compiled in 32-bit. So the first command here, the NOS-M, the -f elf32 indicates that we will compile the sources.s file to a 32-bit ELF binary format. And what does ELF stands for is the executable link format. And this is a pretty common file format for executable files, object code, and shared libraries. However, if you want to like execute a 64-bit, you can just do ELF 64. The next command will be object dump. More on that later, but there's actually two ways to like for shell code, there's generally two.
So it prints out the hex code, like the assembly code. When you assemble it, it gets turned to the machine code, and when you're doing the object dump, you're listing all like the opcodes and stuff.
Yeah, and also so when you obtain machine code, you can either use an AT&T syntax model or the Intel syntax model. In this case, we'll be using the Intel syntax model. And the final command we'll be using is the linkage editor, where we'll linkage the output file with the executable.
Yeah, this command, it turns the object file into an executable. It is not like with, let's say, when you compile a program like a C program, you directly go to the from the source to executable. You have to assemble, and then you have to run the linker to make the executable.
So the first task is task 1A. And basically within this task, we're more setting up information and like understanding the whole purpose of shellcode. And like we mentioned before in the commands, we do see that we're using the NASM for the my.sh.s file, which is the code on the left. It's an assembly code file, and we'll continue to input the commands from listed above. And then after that, we'll see there's two shell IDs, and it's especially important here that we recognize that both of the shell numbers itself are different. And this is a good thing because it indicates that a new shell process has started. And when attacking, we only need the machine code of the shell code. So the machine code can be obtained from the target file or executable file. And like I mentioned before, we don't need all the values. We just want to get all the values before the zeros turn into like this hex value. And here, next slide. So this is the Python code that was given to us in the seed lab. And here we can see that we're converting the value from above. You see in the image on the left, there's the hex code that we copied, and then we're going to convert that into a shell code using this given Python program. And after running the command, we'll see that the length of the shell code itself is 27 characters, and then we'll see the actual shell code itself.
Okay. All right, so here, this is like just a screenshot. Let me actually run it. So let me bring up, I'm using Kubuntu. This is VMware. All right. And right, instead of VirtualBox, it's a bit faster this way. So, let's assemble my shell. We'll do the object dump. Why not? Here we go. As you can see, there are no zeros, no extra zeros, no. And then let us run. Okay, so now we have it. We've made the executable. This is the process code or the process ID of bash. And as I had printed before, if I remember this correctly, we see that we are running bash. We're running the born again shell. So that's one shell program. Oh, and when I was talking about the prompt, this is what I mean by the prompt. Dude at dude's virtual machine. That's the prompt I get because of how I chose my username in the virtual machine. But yeah, so now when I run this, when I run my shell, all we get is this $sign, so we don't get the prompt. That's one clue. But if someone was actually trying to trick someone, they'd make sure to get this prompt too. The other way you would find out that something is off is run this. You see the process ID is different. You want to be sure. Echo $0. You see that we are not running bash. We're running this other shell program, one that's a little more stripped down. And this program isn't actually, we did not write an actual shell program. This is already in Ubuntu. We're just passing, where we just wrote a program that tells Linux to launch, or Ubuntu to launch this other shell program instead. And you cannot get out of this by Control-C trying to pass interrupt. So let me exit out and go back to the slide. So the user doesn't realize this, doesn't realize they're running a different shell. You could like get mischievous and start adding things like keyloggers, where every command that gets passed into like the other shell program, or if you actually want, especially if you actually wrote your own shell program, you could, you know, log everything the user enters, get their passwords, get their habits, what commands they regularly run, so on and so forth. Have it all logged in a file in a directory the user is not aware of, and so on. Let your imagination run wild with that. Because if they're not looking at this out of habit, you know, that's all it takes. Okay.
Yeah, let's wrap up the presentation. Yeah.
Oh, all right. I'll try and hurry up, but there's a couple more things I'd like to address.
So for this task, we are tasked of trying to eliminate these zeros. And in this task, we're supposed to maintain the 32-bit value without changing the amount of bytes written in the command line. So in order to do that, we the original code for push would be push //sh. We changed it to /sh and a space, which maintains the 8-byte requirement that was in task 1B. And we can see that reflect after running that code, that it does maintain the integrity of having 32-bit on the picture on the right.
Okay, let me get this real quick. So task 1.c, we're not running a shell program anymore. Instead, what we're doing here is we are passing we are passing whatever arguments we want directly into directly to bash. So like this one, the original, what it's supposed to do is like do ls-la, and I run the program, it prints this out. Well, watch this. I'm going to do something more fun. I replaced it with rm this was a star. Okay, you know what that does? That's going to delete everything in the folder it's in. So if I have it's already compiled here, I called it do not run, and now if I run do not run, it deleted everything. So that's nice.
Yeah,
you can add as many arguments as you want and do great things. All right.
To hack, right? Not grading.
So yeah, add more arguments, add whatever commands you want, and the only thing that I had trouble with was reducing. When I did the object dump, I wasn't able to get rid of the zeros, but otherwise, yeah.
Yeah.
Task 2,
can I stop here? So
yeah.
I think it's too much time over time. Yeah. I think if we have a time, so I will let you know, come back to discuss task 2. Okay?
All right.
Is it okay?
Yeah.
It's a good presentation, good explanation. Thank you.
Thank you.
Yeah. Yeah. So next group will be, are you there, Adrian?
Yes.
Yeah.